This time on Catalyst. Top-level male athletes are usually faster and stronger than females. So what will happen to this runner's performance as she transitions from male to female? And bad feelings? We'll show you new science that aims to take you from beat down to upbeat. It's done with a drum. Also, they're astronauts and twin brothers. They've both gone to space to find out how our bodies might change when we travel to distant destinations like Mars or beyond. This YouTube edition of Catalyst is brought to you by Arizona PBS and Arizona State University. Life has problems. Science turns them into questions that can lead to solutions and even innovations. This is Catalyst, shaping the future through science research at Arizona State University. Welcome to Catalyst. I'm Professor Vanessa Ruiz. Science keeps finding new connections between our bodies and our minds. Food, exercise, what we eat, and what we think all intersect in some way. This time on Catalyst, we begin with a very fit and very interesting person. Her name is Lauren. While she has spent much of her life being strong, fast, and competitive as an athlete, she isn't yet the person she feels she's always meant to be. Lauren is transitioning from male to female. That takes courage. What is daring to is that Lauren is allowing scientists to study intimate changes in her body as she makes this transition.
It just feels like I'm free. Honestly, like my passion, and the love for that sport is everything to me. Like I can't imagine life without it.
Time of 1 hour and 29 minutes.
This is Lauren. She's a highly competitive distance runner. She's won dozens of races and competed in the Boston Marathon.
Go get 'em!
Running is a large part of her identity, but an even bigger part is undergoing change.
How's it going?
Lauren is transitioning from male to female.
Not being able to be who I feel I am, I was just like, I'm tired of this.
Most of us, we learned that gender and sex were the same thing and that it was a dichotomy that you're either male or female.
We're trying to fit bodies into one of two categories when there just aren't two categories of people in the world.
But it turns out that that's not the case, that it is a spectrum, that it can be anywhere in that, and that those three variables, biologic sex, gender expression, and gender identity, can all be discrepant or different.
Changing her gender may change her ability to compete as a runner.
Just because an athlete might think it's unfair that somebody who's a transgender woman is now competing in the woman athlete category, that's just how it is. All of our bodies fall on varying places along the spectrum of gender. One body can actually move along that spectrum.
Right now what's going on is that physiologically she's being rendered female.
There's not a lot of data or clinical studies that have been able to tell us, for example, what does exogenous or estrogen that we give somebody that's transgender mean for them in 20 to 30 years.
What they find may help answer an important question. Do transitioned athletes gain a competitive advantage over cisgender athletes? Cisgender athletes match their gender identity with the sex they were assigned at birth.
Personally, I take the side of the biological females because that's why the category exists. So in my article, Sex and Sport, I actually agree with the position that if an athlete has gone through puberty as a male, they ought not to be permitted to compete in elite female events because they retain some structural advantages that female athletes just simply don't have.
On this journey, Lauren is allowing researcher Sid Ungadi and his team at Arizona State University to measure these ongoing changes in her body and in her athletic performance. They're looking for changes in her body's ability to use oxygen, Changes that could affect speed, strength, and stamina for Lauren.
It's a pretty long testing day. It takes about 6 hours from start to finish.
Keep pushing. That's fine.
It's all been positive, and I look forward to those tests every month.
The team is monitoring Lauren's heart. Here, they're measuring bone density.
You may feel a little claustrophobic at first, okay, but let me know if it's too much.
With a face mask and a treadmill, they're looking for changes in her blood's ability to use oxygen during intense exercise.
Push. All right, straddle the treadmill. There we go. As soon as it gets
Good
there.
job.
Nice job.
Did great.
I love running fast. I love pushing myself as hard as I can.
The biggest surprise, I think, was how quickly the performance got worse after she started the hormone therapy. When she started this study, at peak exercise, her heart, on average, was putting out about 140 mLs of blood per beat. Now it's putting out about 80. So as she gets more pronounced testosterone blockade, the oxygen carrying capacity of her blood is going to start going down, and that'll drive her performance down as well. Regarding if she'll retain a competitive advantage against women, we don't expect that she would.
I feel like the science, like especially the hormones, has affected me. Like I just can't reach that next step like I used to.
We might well one day have to actually use the concept of an athletic gender, not use the standard biology of sex, like male-female, but rather define athletic gender based on hormone levels.
This is someone who's taking incredible risk by staying in sport. At the end of the day, if you're doing what you love and you're doing it in a way that's authentic, if this is someone who's living their true life as the person they know they are, that's a very different thing.
I am all about competing honestly and fairly and not, doing this just because. It's not a just because for me, it's because this is who I am.
She's absolutely losing something she's pursued her entire life in terms of performance, but I think within all humans we have a sense of priorities. The fact that she's going through with this means that one is clearly a much greater priority than the other. We don't even know what the long-term health outcomes of these things are going to be, so hard to say how it's going to turn out.
I just want people to think that I am a genuine, honest, loving, kind, honestly, grateful for all the friends that I've had over this. I mean, there's been some moments where I just seriously wanted to give up, but it's just better to be myself. I'm tired of hiding.
We will continue to follow Lauren's story in the months ahead as she continues her journey. Not just the science, but also the challenging emotional steps that she will be taking along the way.
Our arms up, right up to the ceiling, curling your fingers into fist, and strong exhale, tightening everything.
I was diagnosed in October of 2017.
Treatment is usually part of beating a disease or health crisis, but sometimes that treatment can take a toll on a person's body and spirit. Things like chemotherapy and radiation are especially harsh. So is cancer surgery, like a mastectomy. For cancer survivors, the time between being sick and healthy is often marked by fatigue, what some patients describe as a mental fog. Now, researchers are finding new ways to help patients cut through that fog and feel healthier faster.
I had no indication or idea that something was wrong. I had my treatment for breast cancer at Mayo, and one of my last appointments was an oncologist, and he made several recommendations about how to improve my health going forward, and one of them was that he suggested that I try participating in this study, particularly because he said it's supposed to address fatigue in breast cancer patients.
We have a study ongoing now that incorporates several interventions that have been shown to be helpful to some degree or another with breast cancer survivors who are somewhat fatigued and have other symptoms like chemo brain. It's got a name that women with the condition have coined themselves. And the experience of feeling fuzzy-minded after treatment has been most profoundly associated with certain types of chemotherapy.
The study is testing how 3 types of treatment help improve chemo brain. One is slow and meditative, like yoga. Another is faster and focused on exercise. The last is structured, like a support group.
The big question we're asking with this research is, first, can we distinguish amongst these 3 different interventions for what might work best for the primary outcome of fatigue to help women to really recover and feel better.
After my surgery, I had a problem called axillary web syndrome, which affected my right arm, and after the surgery, I couldn't lift my arm past my shoulder, essentially. But this movement has really helped me regain full motion in the right arm, just full extension and flexibility.
There is so much information out there about how these practices help. The healthcare field still is very, very dominated by a view that says when something goes off, there's a pill to fix it. I would like to think that the work that we're doing is adding a little drop to the big bucket of change that is going on.
For all of us, part of our mental health comes down to our inner voices, what we say to ourselves about ourselves. For example, we can be too critical about some things, too discouraged about others. Well, now there's a technique to help that involves drums and not drugs. It's called cognitive restructuring. It is aimed at helping people with depression or anxiety, and it makes use of the simplest of musical instruments to help retrain your brain.
When you get out the drums, people are either like, or they're like. Cognitive restructuring is being able to identify negative thoughts that you're having, generate some more caring, kind, positive alternatives of things you could say to yourself instead, and learning how to catch yourself when you're having the negative thought and change it to a more positive thought, and being able to put that to a beat. When you're on the brink, you can change the way you think. Pay attention to the power of your thoughts. Take power from the meaning of your words. To use rhythmic reinforcement to make cognitive restructuring more memorable and hopefully more fun. And if it's more memorable and more fun, maybe people will be more likely to use it. First step of this method, as you know, is to help the client identify what some of those negative messages are. But then for every single negative message they come up with, you're also trying to help them find a positive alternative.
It's a way of communicating history and morality, I suppose you could say. You know, it's one thing to tell somebody something, to warn them or say don't do this. If it's incorporated into music and heard often, it tends to stick in people's minds more, especially children. That has made it handy for things like the language and the cognitive restructuring, because that tie is already there. We just changed the language.
Because it's energizing, that it has the potential to really convey really positive messages.
You are bringing something to somebody. You are making their day better somehow. They might not even realize it. You know, to be a musician is to be a healer, and don't take it lightly. Have fun with it for sure. You know, you always want to have fun when you play. But realize that what you're doing may really be having a profound effect on somebody else.
Christina Cook, your record holder, she is out, thumbs up, and a huge smile.
It was really just about the kind of the mental cheerleading that you do to yourself. Make sure to put something, in your mental space that brings you up. And for me, that was always focusing on what I had and not the things I didn't have. Focusing on the unique aspects of my life that one day I would just wish I could have back for a second.
Christina Cook recently returned after spending 328 days in space. She is now the woman who has spent the most time in space. The isolation in space can be challenging to the mind, and the radiation and lack of gravity can cause changes to your body.
A lot of people, because of the different neurovestibular system things and changes that go on for microgravity, when you're readapting to 1G and to Earth, you might experience some motion sickness and things like that. I'm really fortunate in that I have not experienced that, but what I have noticed is that my balance has taken a little while to get used to. So the physical act of walking was something to get used to.
Cook was in space just 12 days less than another American astronaut, Scott Kelly. Both Cook and Kelly are adding to the knowledge we'll need if humans will go on long journeys, like a trip to Mars. In March of 2015, astronauts Scott Kelly and Russian cosmonaut Mikhail Kornienko began a 340-day mission on the International Space Station.
And liftoff. A year in space starts now. Kelly, Kornienko, and Padalka on their way towards the International Space Station.
With the help of Scott Kelly's identical twin brother, Mark, researchers were able to observe the impact long-duration space stays have on human health.
So my brother spent a year in space aboard the International Space Station. He has a total of 520 days in space, where I have about 54. Space environment, it's pretty challenging for human physiology. There's a lot of radiation.
Michael Gorel is an ASU engineering professor. Gorel is interested in extreme environments like space and has questions for Mark Kelly about the study and how it might change plans for any potential trip to Mars.
What's the difference between your and your brother's DNA?
Where the differences currently lie between the two of us have to do with what's called epigenetics, which is how your DNA responds to stress and responds to outside influences. His changed in space, and 7% of it still remains changed today. But that doesn't mean that his DNA is different.
The focus of our study was to investigate how the epigenetics differed between Mark and Scott, and also just within Scott from his time before he went on his mission, during his mission, and then how it looked after.
Epigenetics is information in addition to your DNA sequence that tells genes not what they are, which is what the DNA sequence does, but what they should do. So where the DNA sequence are the letters and words of our genome, epigenetics is kind of the grammar.
So our main finding in the epigenetic study was that we saw variation in DNA methylation and epigenetics in both Mark and Scott. And what was perhaps surprising to us is that we saw just as much variability in Mark, if not more, in fact more, than we saw in Scott.
You can't say that the differences that we see are related to spaceflight itself.
That could be attributable to many different things, including the environment on the space station. You're in an isolated space for an entire year, whereas Mark could travel the world if he wanted. Also, the diets are going to be very different. Mark can eat whatever he wants, whereas whatever gets delivered to the space station, that's what Scott has to eat. For epigenetic studies, for what we needed, it's very important for us to get freshly isolated cell types out of the blood. Well, to do that, we have to have freshly isolated blood. So what Scott actually had to do on the space station was when they were getting a delivery of supplies from Earth, he had to draw blood that day and put it on the spaceship that was going to return that blood home. We actually had samples within 38 hours of blood being drawn on the space station to back in the lab here on Earth, which is quite a feat in and of itself.
When he came back, just like every astronaut, you go into space for 2 weeks, you come back, you're going to be taller for about 30 seconds, and then you're not taller anymore. So he was 2 inches taller for a very short period of time. You lose bone mass, you lose muscle mass. My brother's heart lost about 2% of its mass while he was in space because it doesn't have to work so hard. Without gravity, the heart doesn't have to pump very hard. It also affects the muscular system around your circulatory system in your veins and capillaries and arteries. That got weak. His vision was changed significantly. Astronauts who spend a longer time in space wind up with vision issues. Something happens to the optic nerve. It changes shape at the back of the eye, and it affects people's vision, sometimes significantly. But if we want to send people into space for 2 years, 2.5 years maybe, to go to Mars, we're going to have to understand this a lot better.
I have been lucky in that I haven't experienced all of those things. You know, a little bit of muscle aching is definitely going to be across the board something that you experience when you have to use new muscles that you haven't learned to use in, you know, however long you've been in microgravity, whether in some ways even just a normal duration ISS mission. We have great countermeasures so that we don't lose a lot of our bone and muscle mass like we may have done, you know, in decades past when we do long duration. But some of those fine stabilization muscles that you use just to do simple things like walking, we have lost. So I do notice little, you know, discovering muscles I haven't felt in a while and things like that.
My longest flight was 16 days. The effect on the body it's noticeable. You get back, you don't feel well, your neurovestibular system's all messed up, you're incredibly dehydrated. Your muscles really hurt because you don't really use much of them in the time you're in space. So, you know, those effects are very noticeable. You know, that's magnified by a factor of 10 if you go into space for 6 months, or in my brother's case, a year. It takes some time for you to recover. From what we've seen is that the recovery time from a space flight is about the time you were in space. My brother's 1 year space flight, that took him about a year to where he started to feel normal again.
What would you want engineers to help with to make these long-term missions possible?
Well, we have to figure out the engineering of getting a vehicle to the surface and then staying there for a long period of time, and then getting that or another vehicle to return the crew to Earth. That's kind of complicated. That's why some people have at least started to talk about, some of them are no longer talking about doing this. I don't think it's a good idea, but sending people on a one-way trip. I think it's a horrible idea.
This is not really something that I personally am on board with because Mars looks like a very hostile environment.
People aren't going to like to live on Mars for the rest of their lives and to die on Mars. You know, it would be like if somebody sent you to Death Valley. Would you want to go live in a camper in Death Valley? And by the way, you can't go outside without putting a suit on.
Before someone thinks about living on Mars for a year, they should probably think about living on Antarctica or living on the top of Mount Everest for a year and see how much they enjoy that.
Not the perfect scenario for a happy and healthy crew on another planet. So we got to figure out how to bring them back. And when we figure that out, you know, that's going to make a trip to Mars a lot easier from a lot of different perspectives.
Here in Arizona, we're told to cover up, put sunscreen on, and do everything we can to protect our skin from too much sun. Too much sun exposure puts you at risk for skin cancer, but the sun stimulates our bodies to produce vitamin D, something we need to stay healthy. There are a very rare few people, though, who have too much vitamin D. And this can have bad effects like kidney failure and weaker bones. A receptor in our bodies controls our vitamin D, so finding that receptor could help developing in treatments. Researchers at Arizona State University have been working on a solution for people with too much vitamin D. They suspect this process for balancing out vitamin D levels will also be applicable to other drugs and therapies for diseases like Parkinson's and Alzheimer's.
For the past 2 years, I've been doing research on compounds which would act as potential vitamin D antagonists. The role of an antagonist is to lower or block biochemical response by binding to a receptor and not activating it.
Receptors are very integral parts of the body and human health. The vitamin D receptor, of course, helps regulate bone homeostasis.
To make the new substance, the cells have to be prepped.
Going to give it a gentle swirl just to make sure that all the cells have been properly cleaned.
Then you cover the cells in an enzyme and let it soak for about a minute.
Covered with the enzyme.
For the last step, you add the media, the red liquid, and pipe it up and down to make sure the cells are not clumped together.
Once the cells are cleaned and separated, they go to the microscope for a closer look.
So in the context of cancer and neurodegenerative diseases, many receptors are targets for drug design. Right now there's no good treatment for diseases like Alzheimer's or Parkinson's that is very effective. So I think there's compelling motivation to attempt to create new drugs that might impact pathways that are critical in the progression of those diseases in order to better understand how those diseases progress, but also to develop potential new therapies for them.
I'm Professor Vanessa Ruiz. Thank you for watching Catalyst, our show about how science looks for answers and also looks for solutions to problems in our lives. And because science always has new questions, we'll be back soon with more stories.
Catalyst is supported by Knowledge Enterprise Development at Arizona State University, advancing entrepreneurship, innovation, discovery, and knowledge for the public good.
Subscribe to this channel to see more episodes of Catalyst on YouTube.